anti-gingival, disease control, anti-cancer, but the one that we are interested in is anti-infective that we're going to talk later. What is Hyptis crenata? It's aromatic plant, widespread in the field. They are popular use against skin disease, nasal congestion, gastric disorder, and pain. What are our aims in this project? First, we're going to define how we're going to prepare this extract. How these people prepare this extract. We're going to do a standard procedure for that. And after that, we're going to analyze the compounds inside of this extract. And finally, we can evaluate the effects from this extract in animals' model. So here is our result of the experiment. You can see here people is using, and then with this 5 different extracts, we do the analysis from GCMS and HPLC. And so we also can do the pharmacology trials from this extract, and that's going to be anti-infective test. So our results so far. We already did the traditional method because we went to Brazil last year. We went here in the 2 communities in Brazil. The name is Labela and Poço Feijão, and we did the questionnaire with the people. And then what we have is the people said that they using these plants, the majority you can see here in this pie, the majority is using against pain-related use, and then you can see pathology for this is they use as a tonic, like fever, nasal congestion, and a small part is the prostate cancer and also for worms. So, how these people is preparing Hyptis crenata? They prepare Hyptis crenata in 5 different ways. They have the coction that as a majority they use boiling water. And also they use an infusion of the tea. They put the water in material and cover that. And also they do a cold extraction. You can see here that they use water, 50% alcohol and 40% alcohol. They have cold extraction in different concentration. So what we have from analytic compounds in this extract that we are imagining the 5 different extractions. Here we see here the different extracts in the lab. You can see different colors, different concentrations, and here the HPLC only to illustrate here. When they do the coction, they use a higher temperature, which is the reason that they come up with the compounds, And also here, for 40% alcohol, they use a more concentrated solvent. This is the reason that they have another compounds. So, I would like to ask your attention for this graph here that show the phenolic chemical compounds in HPLC. You can see here the rotation time, and then the thing is, you see the peaks in the rotation time, they come at the same time. It means in HPLC that the different, this peak is similar compound. You can see that the different lines show the different extractions. However, the only different extractions, you can see here 40% alcohol in brown. You can see the peaks come early and then later. And then it's a little bit different because, like I said, because it's different concentration and so on, then you come up with different peaks. So we did the spectrum here in this peak, and then we suggest that this compound might
Thank you very much. Let me have any questions for Graciela.
When you went through the survey of the traditional users, who did you interview? Did you interview the traditional dealers or just local people, and how did you select them?
Yes, what people that traditional users is a kind of leader of the community. The people that they are known for using this crenata, and also for recommending it's a kind of doctor, and like I don't know the name in and because I had also a doctor in the place that, like, for example, you're ill, you go there, and then it's okay.
Any more questions? Yes, Alison?
I don't know if you when you're developing a drug, you describe how you develop a drug in terms of phases. Phase 1 is a molecular description and the effect in cellular experiments description, and then you go into animals.
Yeah.
So you're going to go into pain models in mice, but still you don't actually know how it's working in the molecular ground.
Yeah.
That is my question.
No, I prefer, because when you have, because about the way that when you study, this is the reason that I did the traditional history way, that when you study medicinal plant, when you have the people using for a long time in their lives, then I think you're able to test an animal pharmacology, because it's a large trial, like these people is using for their whole life, like these people are 50, 60, and in theory we can go this for mice, because these people are large trial. I don't know if I'm answering a question, right?
My ground is more maybe an
More
ethical ground.
molecular.
You're doing a pain model in animals, and still the molecular effect hasn't been described. So
yeah, I see what you mean. We need another way around, because we don't know how this plant works, right? And then we need to do the protocol to see if we cannot do different, because we're going to give this for animal, and you see if the animal you answer for this plant, because otherwise you're going to spend more time doing the molecular things of that. We need this answer. We need that might give our answer. We cannot avoid that.
well, you can do an nociception assay with isolated nerve, for example.
It is another way that we can do that, but to be honest, when we give the mice protocol, it's more effective for this, and because I know the program here to work with animals, but I have been working with animals, and it's clear that it's better when you have the opportunity to see this.
Thank you very much. As everybody else, Gabriela will be around in the break, so if you have any further questions, just go and see her. I'd like to thank all the speakers of this session again, and give them an applause, actually.